Hello, I'm Sean Wu. Today we'll show some demo tests by using SoundViewer to locate multiple sound sources in a non-ideal environment. The objectives of demo tests are to address concerns and questions that people may have for SoundViewer. The equipment needed for performing these demo tests are kept as simple as possible. The signals used in these tests are made as common as possible. And finally, the test environment is kept as normal as possible, such as a typical office or lab. No anechoic chamber or semi-anechoic chamber are needed in performing these tests. The hardware needed for performing these demo tests is the SoundViewer system. Case number 1, tests of the dynamic range and spatial resolution of two incoherent sources. A speaker producing frogs at night, downloaded from the internet, was used. The overall sound pressure level from this speaker is around 80 dB. The highest sound pressure level from this signal is 72 dB. Another speaker producing white noise, also downloaded from the internet, was used. The highest level is at 52 dB. These two incoherent sources with very large dynamic range, more than 20 dB, were used. Results show that when a separation distance was less than 15 cm, SoundViewer can easily separate them. Those are the results after CAT scan was used, where the resolution of these two sources can be enhanced further. Now we put these two incoherent sources with very large dynamic ranges, more than 20 dB, right next to each other. In other words, the separation distance between these two sources was essentially zero. And results show that SoundViewer can still easily separate the two. These are the results after using CAT scan, and the resolution of these two sources can be further enhanced. Case 2. Test of the spatial resolution for two coherent sources. Here, two coherent sources were driven by the same source, specifically two earphones connected to the same laptop computer producing white noise was shown. The separation distance between these two earphones was less than 15 cm. Results show that SoundViewer together with CAT scan can identify these two coherent sources. In this case, two earphones were connected to the same laptop computer producing a narrowband sound, which was obtained by applying the Henning window to the white noise signal downloaded from the internet and centered at 425 Hz. The separation distance between these two earphones was less than 15 cm. Results show once again, SoundViewer together with CAT scan can identify these two coherent sources. Case 3. Test of the spatial resolution for two incoherent sources. Here's one earphone producing white noise downloaded from the internet. Here's another earphone producing pink noise, also downloaded from the internet. Now we put these two earphones right next to each other. In other words, the separation distance between these two earphones were essentially zero. And results show that SoundViewer together with CAT scan can identify these two incoherent sources, even though their separation distance was zero. Case 4. Test of float noise. A hairdryer was used in this case. Typically, the flow speed generated by a hairdryer was very low, but the flow noise at the exit nozzle of this hairdryer was very obvious. This is the front view of this hairdryer. As you can see, flow noise at the exit nozzle of this hairdryer was very obvious. This is a back view of the hairdryer. The noise generated by the blower in the rear of the hairdryer was also very obvious. Now we place a thin plate in front of this hairdryer. As the flow exiting from the nozzle of this hairdryer hit the edges of the thin plate, flow interacted with the edge structure and generated leading edge noise and turbulent noise. Case number 5, test of cell phones. Here is one cell phone producing white noise downloaded from the internet. Here's another cell phone producing frogs at night, also downloaded from the internet. Now we put two cell phones right next to each other, one producing pink noise and the other producing violet noise, both of them downloaded from the internet. Results show that SoundViewer can still identify these two cell phones. Now we stack these two cell phones on top of each other, one producing white noise and the other producing frogs at night, both of them downloaded from the internet. By using SoundViewer together with CAT-scan, we can clearly identify these two sources. Now we put these two cell phones on top of each other, but with a side offset, one producing white noise and the other producing pink noise, both of which downloaded from the internet. Once again, by using SoundViewer together with CAT-scan, we can clearly identify these two sources. In conclusion, SoundViewer can be used to locate a plurality of sound sources in a non-ideal 3D space over the entire frequency range, for example 20 to 10,000 Hz, at a very large dynamic range, larger than 20 dB, and a very high spatial resolution through CAT-scan. In particular, SoundViewer can handle multiple sound sources that emit coherent, incoherent, narrowband, and broadband signals in a non-ideal environment. Thank you very much for your attention. For more information, please contact me at Sean Wu at signal-wise.com.